Now let's spend some time to discuss the antiviral drugs that are used to treat the herpes viruses. Do you remember what kind of viruses the herpes viruses are? They are double-stranded DNA viruses. Very good. The drugs listed here include acyclovir, famciclovir, and valacyclovir, and they have activity against the varicella and herpes simplex viruses, but they do not have activity against the cytomegalovirus. The drug ganciclovir, which is another antiviral medication, is what is active against CMV. These three drugs, plus ganciclovir, all work by the same mechanism of action. They are guanosine analogs that inhibit viral DNA replication. Thinking back to our biochemistry, do you remember, is guanosine a purine or a pyrimidine? It is a purine. Very good, along with adenosine. Now, you wouldn't be crazy if you asked me, Kevin, well, guanosine is used in our own cells, DNA replication, so why don't these guanosine analogs kill our own cells, or why don't they affect our own human cells? Well, I'd say that's a very good question. And the reason is because these medications are activated by kinases that are only found in cells infected by the virus. Our uninfected cells do not have this kinase, and therefore these drugs are not activated. Thinking back to biochemistry for a moment, do you remember what type of reaction kinase enzymes catalyze? Kinase enzymes phosphorylate molecules. They add phosphoryl groups. So, in this situation, with acyclovir, for instance, there's a thymidine kinase that monophosphorylates the acyclovir. So it takes the acyclovir and adds a phosphoryl group. And then this monophosphorylated guanosine is then further phosphorylated into a triphosphate form by cellular enzymes that exist in the human cell to form the drug that then inhibits the viral DNA polymerase. So this is the form that inhibits the viral DNA polymerase. And this A here is acyclovir, should not confuse you as being adenosine. Now, unfortunately, some viruses are able to become resistant to these medications by mutating the viral thymidine kinase so that the step of activation can never happen. And if this part doesn't happen, then it cannot be further activated into triphosphate form, and it cannot inhibit the DNA polymerase. So it is important to know that these drugs are only active against the acute or reactivated infections and are useful in reducing the severity of the reactivated oral or genital herpes infections. They are also effective against HSV encephalitis. Unfortunately, these drugs can cause a crystalline nephropathy if the patient is not well hydrated, which can lead to acute renal failure.